Okay, so here's an example on how you can compute for the percentage composition, showing you the computation by hand. So for example, we are given the compound of water. We all know that water is composed of hydrogen and oxygen, and its chemical formula is H2O. So to compute for the um, molar mass of hydrogen, let us start with the hydrogen. So you have two atoms of hydrogen, and then you are going to multiply it by the atomic mass of hydrogen. If you look at your periodic table, you can see that the atomic mass of hydrogen is 1. So you are going to multiply those two. So you would have 2 grams per mole as the atomic mass of hydrogen. And then for oxygen, you have only one atom based on our chemical formula, and the atomic mass of oxygen is 16. So you have 16 grams per mole. Now to get the total mass of the compound, all you need to do is to add these two. So you have 18 grams per mole as the molar mass of our compound. Now, to proceed, we are now going to compute for the percentage composition. Let us have the percentage composition of hydrogen. Okay, so we are going to divide the molar mass of hydrogen by the total molar mass of the compound, and then multiply it by 100. Now you can use your calculators with this, and you will derive with the answer of 11.11%. So that is the percent composition of our hydrogen. Now we go to your oxygen. Finding the percent composition of oxygen. So oxygen has a molar mass of 16 grams per mole. Divide it by the total molar mass of the compound and multiply it by 100. Again, using your calculators, you are going to derive with the answer of 18.89. 18.89%. So if you are going to add these two up, you are going to get 100%. Again, the percent composition that we have is 11.11 for hydrogen and 88.89 for oxygen. Okay, so let us have another example. Another example that we can use for your computation, or as an example of your uh, or as an example of your okay. For our next compound, let us have sodium iodide as an example. So you have sodium iodide, Na, and then you have iodide with the capital I. So you can see that we have one atoms involved for each element in our compound. So again, to get the molar mass of sodium, you have one atom multiplied by the atomic mass of sodium, which is, using my periodic table here with me, which is 23. So you have 23. So that means the atomic mass of sodium is 23 grams per mole. And then for your iodine, identifying its molar mass, again, you have one atom multiplied by the atomic mass of your iodine. Where is my iodine? Which is 127. 127. So that would give you 127 grams per mole. So to identify the total mass, you are going to add 123 by 127. If I'm not mistaken, you are going to have this by 150. Let me just check. So you have 150 as the total mass of the compound. Okay. So again, with the percentage composition, let us have the sodium. Percentage composition is 23 grams per mole divided by 150 grams per mole times 100. I'm going to use my calculator with me. You have 23 divided by 150 times 100 would give me 15.33%. Okay. Now for the percentage composition of your iodine, we have 127 grams per mole divided by 150 grams per mole times 100. That would give me 84.67%. So if we add these two up, you would get a result of 100%. Now for those who are asking, how about the unit? So you can actually see here, we can cancel the units, grams and then mole and mole. So you are left with the percentage for the 100. The same way with this one, grams, mole and mole, you can cancel that out, leaving you with the percentage. And that is how you solve for the percentage composition of your compounds.